Okay, so that was easy. Now let's delete B. So if I delete B, so I of course traverse, find B, and now I try to delete B. And when I delete B, I have to do another adjustment operation. So I push D and get C to the left, then everything is all right. What would happen if I delete E here? So so look at this. So E is at the root and E is here. So I'm going to remove the root element itself. So if I come here and I find E and I remove E, then I have F and G here. So everything here seems all right, but what should go to the top? Yes, by now you should have figured this out. So I look for E, I remove E. Now F becomes the first data item of that node, and it's sufficient to replace E with F in the root node. Let's remove F again. There's no F now, so G. So what happened here? So now we realize that we don't need a complete level altogether, and we have flattened one layer. So let me skip back. uh, what happens if you remove um, G or F? So let's remove G. So we are removing G here. Okay, so let's remove F. I mean, I'm back to the old state now. I'm doing that G delete, and now I'm trying to remove F. So when F is gone, there's only G, and G goes to the middle, and now we don't need one layer. I can reduce one layer. I urge you to use this tool, play around, and understand in more detail how this actually works. Let's go back to the slides. Okay, so we just saw how to do how to populate B plus trees. So I was, yeah, so here is the B plus tree explanation with max degree as 4 or fan out factor as 4. Then if it was 6, it would have looked like this. Um, and as I showed you, every node is structured as follows. There is a pointer, there is a key, there is a pointer, there is a key, and so on. And these keys are ordered. That's another thing that you should keep in mind. And the leaf node points to the corresponding records. There are some rules on how to populate and how to delete nodes from this tree, which I showed through an example. The same thing is written over here, which I urge you to read yourself. So here is an example. Initially, I insert Sri, then I insert U, then I insert Mozart. So everything so far is good. So note that they are getting inserted in order. And then when I insert Einstein, assuming my fan out factor is only 4, I cannot add Einstein at the end, so I have to break it. So I keep Sri in the middle and have these two at the as the child nodes, and this continues from here. So we saw this with the visualization of how the insertion and deletion works. So here, if I were to delete cats, what would I do? So I'll start with Mozart and see whether k is less than m. So I take the left root. and I go through Einstein. I go to the right of Einstein, then gold. K is still bigger than G, so I take the right path and I've located cats here. So I start from the left of this node, so gold and then cats. So I've located cats. Now I want to remove cats. So if you remove cats, you simply get gold and Kim. Everything else is good. So this was a easy example. So similarly, you can try out what happens if you delete gold, what happens if you delete Kim, what happens if you delete else, what happens if you delete mods, sim, and so on. For those who want to understand the algorithm in more detail, it's here. You may take a read, but for this course at least, we will not go any deeper than this. That's all there is. The visualization is available here. I'll leave the link somewhere along with the video as well. Thank you.